Hello, everybody. Hello. Welcome to the first event in the Flare Educate series. First of a couple programs we have with Flare happening this spring. First up, we have Flare Educate, which is a kind of an educational series consisting of 8 different events, which I will describe in a second. And then later on, we will also be hosting a Flare Hackathon in April, most likely, and then a Flare Accelerator for the company-minded between you. First up, let me introduce myself. My name is Nevin. I'm a senior operations manager at Input Club. I will be hosting at least the first couple of Flare Educate events, and then later on you might see my colleague Yasin as well. But for now, be sure that I will be here for the first couple of sessions. I'm sure most of you know who we are. We are Anchor Club. In case you don't know, we are a developer community or a community which organizes educational events in the blockchain space. We do this through multiple kinds of programs. We do it first and foremost through educate programs like this particular program, which is mostly a series of online educational sessions. We also do hackathons. We also do accelerators. We do bootcamps, coding bootcamps dedicated to Web3, but also to AI as well. And then finally, we also offer different kinds of recruitment services in crypto. As I previously said, this whole series will consist of 8 different events. Today and on Wednesday, we will be having first events. Today we're discussing blockchains, EVM, and smart contracts. Then on Wednesday, on the 22nd of January, at the same time, we'll be diving a little bit more deeply into EVM smart contracts. Finally, next week, we'll be going into tokens and oracles. Then next week, next week as well, FTSO deep dive. The week after that, week 3, FDC and FSP by Flare. And then we will be discussing the FDC or the Flare data connector, as you will learn to call it. In 2 different parts on the 5th of February and the 10th of February. And finally, we'll be closing this session, the program, with a session on creating custom FDC types on the 12th of February at 5 o'clock CT or 4 p.m. GMT, whichever time zone you prefer. I'm sure this will be either morning for some of you or late in the evening for some of you as well. Or as it is for us at Anchor Club, middle of the day. Just a short note on our speakers. As you can probably see, all the sessions will be held by one of 2 different speakers, both of them from Flare. Anthony is here already. As you can see, he's on the screen. He will be hosting the first 5 sessions, and then sessions number 6, 7, and 8 will be held by Philip, also from Flare. Finally, feel free to join our community. These 2 QR codes will lead you to, the first one leads to our Discord server, where you'll be finding all the latest information about this specific program, but also about our other programs. This is where all the discussions happen as well, and where we will be posting the recordings of these workshops on a daily basis. You'll also find the recordings on the program website. Speaking of the website, the second QR code will lead you straight to our programs page, where you will be seeing a bunch of different programs appearing, disappearing as we announce them and as we execute them. And that's pretty much it from my side. To go back to the schedule, now I'm welcoming to the stage Anthony Madia from Flare, who will be introducing himself, Flare, and talking about blockchains, EVM, and smart contracts. If you have any question, feel free to pop them in the chat or in the questions tab, and Anthony will get to them very, very soon. Without further ado, Anthony, the floor is yours. Good luck.
Thank you, Nevin. My name is Anthony. I'm working at the Flare network, focusing on DevRel functions. And today, I'm excited to give you your first presentation on the basics of blockchain. Like what Nevin mentioned, we're going to focus on the EVM, smart contracts, and some of the foundational knowledge that will help you get started in terms of building on top of blockchains. We'll also touch on some of the strengths and the weaknesses and keep this presentation at a relatively higher level aimed at beginners, intermediate level understanding that you may have on blockchain, and then use this as a foundation as we progress into more coding functions and getting our hands dirty later. So what is a blockchain? I'm sure some of you have heard of these phrases before: shared digital record, distributed, immutable, ledger. They're kind of esoteric, but let's start with what distributed means. So this means that the data that is on a blockchain isn't held in one centralized location. It's shared across many computers or nodes. Okay. Immutable means that once the information is recorded on a blockchain, it's very difficult to alter or change that information. And finally, it's a ledger, a record of transactions or data. Okay, and I like to keep things simple, so let's visualize a Google sheet. Okay, something a lot of people are familiar with. Okay, a Google sheet. Let's say we have a decentralized version of this that's recorded on a blockchain. You have your sheet. You pull it up on your computer. You can add information to that. You can write on it. Think about if that sheet was shared amongst 10 other people or 10 other computers, they can also add to that sheet. And if you keep with the definition of a blockchain here, imagine that Google Sheet is immutable. Once you add information, it can't be altered. It's distributed amongst nodes, and it's not controlled by Google. It's decentralized. And that's some of the core points about what a blockchain actually is. So let's focus on the right here, on the block 1, block 2 diagram. This is what a blockchain actually looks like: blocks and transactions. Transactions, it's very much like sending cryptocurrency or interacting with a smart contract. And don't get confused by the word transaction, thinking of only in the context of a financial transaction. I would think it more of it as you're attempting to update, read, or write the blockchain. Okay, and those transactions are bundled together in what you would call blocks. And then each block, I'm using the term fingerprint here on my slide. Each block contains the hash of the previous block, and of course, that's where you get the term block chain. And the beauty of the system is that if someone tries to tamper with the block even slightly, it changes the fingerprint, and that break in the chain is immediately apparent to everyone in the blockchain. We're not going to touch on forks and everything else. That gets a little more nuanced because each blockchain has their own rules for breaking the chain happening, etc. But this is the core idea of what blockchains look like, which is a good mental model to keep in mind. Decentralization is also a very big word in the blockchain space. It's a core characteristic of what blockchains are. And of course, this means that the ledger or the blockchain isn't controlled by a single company or government or somebody, but it's controlled by a network of participants. And that could be anywhere in the world. And it does bring some advantages as well to have a decentralized network. You have this increase in security. It offers transparency. Everyone sees what's happening. It's publicly viewable. And some functions may not be viewable. You can choose to keep them private using something called zero-knowledge proofs, which we're not going to go into. The network is also very much resilient. Okay, it's meant to be decentralized, not controlled by anybody, and stand up to attacks. There's also something called the 51% attack, where if you would need to control 51% of the network in order to change it, but that's a very hard thing to do because of something we call consensus mechanisms. So in a decentralized system, you need a way for everyone to agree on the order and the validity of transactions. And we do this through consensus mechanisms. And there's a lot more consensus mechanisms out there, but aside from proof of work and proof of stake, proof of work was really the first iteration of consensus. Um, and what that was, and it's used primarily by Bitcoin. In this mechanism, you have the nodes on the network or the participants in the network. They're expending this computational power to solve complex puzzles. They're trying to find a hash of something. And the first one to do that would get to mine an additional block. Okay, and that contrasts against what is known as proof of stake, where if you're a node on the network, you would become what you call a validator, and then stake or lock up some amount of cryptocurrency to participate in validating transactions or adding new blocks. As an aside, proof of stake is a lot more energy efficient than proof of work. If you're familiar with the merge that Ethereum did, I think 3-4 years ago now, maybe a bit longer than that. That's what that was about, is a transition from proof of work to proof of stake. Okay, so that's a bit of the background and theory on blockchains, from the core concepts that you keep on hearing about. But think about the iterations in blockchain. You've had the Bitcoin blockchain that focused on, you can say, value, the transfer of value, but you couldn't really build on it. It was very restrictive. But with the innovation of Ethereum and the Ethereum virtual machine, we can now transition to programmability on blockchain. So Bitcoin primarily focused on the simple transfer of value. And the next step is programmability. And what this means is that you can go beyond just sending and receiving cryptocurrency. You can build more complex logic and applications directly on the blockchain. And the EVM, or the Ethereum virtual machine, is what allows that to happen. Okay. Now, I'll be remiss if I didn't touch on briefly, how do you actually interact with blockchains? You have a lot of theory behind it, and we'll touch on this in the next presentation. But you have two kinds of accounts on the blockchain that you can interact with. The first is what you would call an EOA, or an externally owned account, which represents a user's wallet. And that's what you're going to be using to send cryptocurrency, to receive it, to send a transaction to a smart contract, etc. And the other type of account is a smart contract. Okay. And that's the account that has a computer program that you can write and send on the blockchain, that lives on chain, etc. And you get cryptocurrency by buying it from an exchange, or you could also receive it. We'll talk more about that in the upcoming presentation. So what are smart contracts? A famous example came from Nick Szabo, where he talked about a vending machine. And he used that example because the vending machine has this core functionality that doesn't change. You go up to a vending machine, let's say you want some Coca-Cola, you put in the code, then you put your money in, and then Coca-Cola comes out. Very simple functions that don't change. So in the terms of smart contracts and blockchain, they're essentially self-executing agreements written in code. Okay, they reside on the blockchain and they're executed by the EVM. Okay, so this offers automation. You can automate a lot of functionality. The contract executes automatically. No one can stop it. It provides transparency as the code is available and written in the public eye. It also reduces the need for intermediaries. Okay, so If the code isn't controlled by anybody and it's deployed to the blockchain, that means that no one is controlling that. If you compare it to uh, Google, Apple, etc., they're in control of their own code. They can make whatever changes they want anytime they want. This is a very different um, model when you're running code on a decentralized network. And here's a very, very simplified version of how smart contracts are going to work. And this is high level because the next presentation, we're going to start writing and deploying code. And quickly, this is Solidity on the bottom left here. That's a smart contract language that we're going to be using. And Viper is another one that's very good, but Solidity is more beginner friendly. And I think the most widely used right now. So the simplified flow is you actually write the contract using one of these languages. You're going to deploy it to the blockchain and trigger that code by a transaction. And when I say deploy to the blockchain, what that really means is that you're uploading that code to the network and it's given that unique address. Okay, so remember the two types of accounts. You have the wallet account, which users use, EOA, externally owned account. Then you have the smart contract address. And that's what you're doing when you deploy it. And when I say trigger by a transaction, this could be a user sending cryptocurrency to the contract or another contract, calling a function within it. And then when that happens, that's when we go back to the Ethereum virtual machine here, the EVM. It executes the code according to the logic defined in the smart contract. And lastly, the state could be updated. Okay, and it is updated if you're triggering the smart contract. You can also send transactions to the chain just reading information, so the state isn't updated. But in this case, the state would be. And if you're changing the data in the blockchain or the state in the blockchain, it's going to cost some amount. It's going to cost a fee for that. Simply explain why that's the case. So I said fee for changing the state of the blockchain, and that might be a little confusing if you haven't encountered this before. Why do users on this decentralized network have to pay something to use it? And the very simple reasoning is that you prevent spam. So if it was completely free for anyone to use anywhere in the world, people can just send these requests or transactions to the network without any cost, and it'll spam the network. So if you want to use the certain decentralized application, you won't be able to do that because the network is so congested with all of these requests, and it opens it up for denial of service attacks, etc. So this fee mitigates that. And when you execute a smart contract, it requires a computational resource. Okay, and that's another place where the gas fee goes to the nodes on the network. So you can also think of gas as a unit that measures the amount of computational effort that's needed for a particular operation. Okay, so tying a lot of this together, the blockchain is the foundational layer, and that provides, again, the distributed ledger, immutability, security, and a lot of the key concepts that we touched on. And at EVM, you can think of it as it's sitting on top of this foundation. It's providing the virtual machine environment where code can be executed and finally, the smart contracts are the actual applications, decentralized applications that are deployed and run within the EVM. And it leverages all the underlying security and transparency, et cetera, that the blockchain offers. And together, all of these things work together to create decentralized applications. So with any technology, they come with strengths and weaknesses. Touching a bit on the strengths of blockchains, you do have transparency, security, immutability. Those are all things that are very good for a system widely used by a large amount of people. Transactions are often public. You can see who deployed it, who transferred what to whom. Security, thanks to cryptography and the distributed nature of the network, are available on blockchains. Immutability, that ensures that recorded data is very difficult to tamper with. And then you have the smart contracts, which allow you to write these decentralized applications not controlled by anybody. So it reduces the need for intermediaries. And ultimately, it does lead to an increased amount of trust, because who are you trusting? You're trusting the network. You're trusting the code. That's another foundational idea. And of course, you have weaknesses aside from all the advantages that it offers. Scalability is a common challenge with many blockchains. So some blockchains struggle to process the high volume of transactions quickly. There's also this cost factor, which can be limiting at times. If there's a lot of activity happening on a network, you have the supply and demand. So yeah, you have this this cost fee, which can be a hindrance to some new users, especially. The complexity is also could be a barrier to entry. There's a lot of stuff you have to learn. You know, if you were to think about telling your grandma how to use a blockchain, that would be a fun conversation, explaining what Ether is, what Coinbase is, what a wallet is. So there's a lot of concepts that are just different from what you would call the Web 2 world that you have to get used to. And also, I'd be remiss to say that there's also a lot of regulatory uncertainty. So if you see yourself being a founder in this space anytime soon, you have to consider what are the regulatory frameworks that are going to take place. Today is January 20th. I happen to be in the United States. We have the inauguration of President Trump coming. He's already appointed David Sachs as the crypto czar. Not exactly sure what that means. But Gary Gensler at the SEC is going to be leaving soon, and who knows what will happen in terms of regulation. So these are things that you keep in mind that are important context. So looking ahead, we are going to, we just covered the fundamentals here of blockchain. Hopefully you found that interesting and not laborious. Next time we're going to talk about smart contracts, getting your development environment fired up, and the logos that I have here are Hard Hat, Foundry, and Remix, which are used to build and deploy smart contracts. Remix is a web-based environment. So that is all for me. Hopefully we have some time left over for Q&A, any questions people would have.
Feel free to post the questions in the chat. We already have a question, can you share the slides with the participants? Is that
possible? Sure. Well, I'm also going to have resources coming up before that I'll just drop in the chat at the right time. For the slides, I think, well, I don't know the best way to send those yet, but we'll
feel free to share them with me on Telegram, and then everybody else, I'll make sure to post the slides alongside with the video on Discord and the video description tomorrow morning. No worries.
Yeah, I think that's the best.
Perfect. There's a question from Adam asking, can you speak about Viper, the other language besides Solidity? Do you know anything about Viper?
Yeah, Viper is a Pythonic programming language. It's I'm trying to think back to the foundations of how it got started. I'm more familiar with Solidity than I am with Viper. But if you're a fan of Python, I'd certainly recommend looking up the Viper contracting language.
Cool. Thank you. There's a question from Judeb. When are we going to start some basic coding on Solidity? I assume in sessions 3 or 4, something about somewhere about there.
I think that's right.
Yeah. So stay tuned for next week. We have first we have a session on Wednesday, and then next week we'll be continuing with some more practical stuff regarding Flare. Also, a question from Judeb: are there any beginner resources you would like to recommend to people who are just starting out building in blockchain?
Yeah, I got started when I got started. Crypto zombies was still a thing. I'll link you that if you want to start looking at Solidity. Put it in the chat. That's a resource that a lot of beginners who want to get started with the basics of Solidity and start going immediately have used, and it's a very good starting point. And I'll share more when we get to Solidity on some other things you can do.
Amazing, thank you. Turning over to the questions tab. First, let me answer a question from Ioana. Yes, I will add it to the Discord channels for the Flare Educate, no worries. But a question for Anthony: how much do we really care about censorship and regulatory concerns in decentralized applications?
Well, censorship is a big deal. I think it was the OFAC governing body that was looking to censor some validating nodes on the Ethereum network. I'm actually not sure of the percentages there, so I'd defer that and I'll research that for the next presentation. But it is something to be aware of, because if you have censored validators, I think there are also some security initiatives in place of hiding the actual IP address of validators. But I have to brief myself on that before I give you an answer. But you should keep it in the back of your mind. I'd focus, if you're a beginner, just focus on the basics, and then you can figure out a lot of this stuff after that with a good solid foundation.
Cool. And to follow up on that, there's a question from Mohammed asking: is it similar to Celestia in any way? If you know anything about Celestia.
I'm not that familiar with Celestia, but
cool.
I think
yeah, go ahead. Sorry, go ahead.
I think they're actually they're a layer 1, I believe. They might both be EVM chains, if I got that right. So Mohammed's saying it also does data availability layer. Yeah, I'm not too educated on Celestia to give a coherent answer to that, Mohammed.
No, that's perfectly fine. Thank you very much for responding anyway. A couple more questions in the questions tab. A question from Mohammed: how easy is it for someone coming from a no-code platform to transition into blockchain development?
No-code platform. Yeah, I mean, if you aim to do something and you're really serious about it, I would highly suggest you familiarize yourself with the code on Solidity, because there's a lot of moving parts. It's a different primitive. I'm not sure which no-code platform you're actually referring to and what applications you were aiming to develop there, whether they were JavaScript based, etc. But blockchain development is fundamentally different than you're building a simple React web app, because you're dealing with a blockchain and all the primitives that I spelled out in this presentation today. So I mean, that's really a personal question that you would have to you'd have to ask yourself.
Cool. Next up, a question about marketability in blockchain. Sushant says, what is the more generalized approach to be more marketable to blockchain and Web3 job market? What should we know so that we can give interviews? So basically, I guess the point of the question is, what basic knowledge should every blockchain developer have to be to do well on the job market in crypto?
Well, my caveat here is that I'm not a recruiter, but I will say you certainly need to know the basics of Solidity and build a good project. I think a lot of recruiters look for what you've actually built before, and some front end work as well, so users can interact with that. So JavaScript, React, Node.js. These are things that recruiters would look for. Know the fundamentals as well. I mean, I'm so surprised that a lot of people in the space don't fully understand the decentralized aspect of this technology. But yeah, that's a really broad question. But knowing the basics will certainly help you.
Cool. Yeah, and I agree completely. Thank you very much for the answer. And the last question, but certainly not least, is about this series itself. Will there be any practical problems that you will be looking at over the next 4 weeks? And will the people have, the attendees have any assignments they could possibly work on after the sessions?
If the attendees want some assignments, I can certainly give some. I did for the coding, I did include some simple things, and I'll package that presentation up into an assignment that you can do on your own time. So we're going to deploy a simple smart contract. I'll help you take that and deploy it on your own time. So yeah, we can certainly do that.
Cool. Yeah, that's about it. Thank you very much for answering all the questions, Anthony. Any
Sure.
final words of wisdom before we close the session off?
Know your stuff. Know your fundamentals. I mean, they're very important. And I'm excited. I'm excited for when I have the opportunity to introduce people to blockchain, focusing on the fundamentals. A lot of people get lost in the tokens and stuff. I think Trump just launched his own coin. Melania launched her coin. These are things that I don't know. They're secondary to your own core understanding of the technologies. So focus on that is my words of wisdom.
No, that's perfectly wise. Thank you very much for that advice. Okay, everybody else, thank you very much for coming as well. And this is, like I said, session number 1 of 8 sessions in total. Anthony will be holding the next 4 sessions as well over the next 2 weeks. So make sure to join those as well. And like we said, from next week onwards, we will be doing some more practical stuff, some coding, some live examples, and we'll be deep diving into Flare itself. Until Wednesday, have a lovely rest of your day, and see you around.
Thanks, guys.
Bye-bye, everybody.